Okay, let's do a little bit more chain rule, and then I want to talk about vertical and horizontal tangent lines. So this is page 23. Go ahead and try part B, page 23. Try part B. I'll skip A and C because I think we should be pretty comfortable with product and quotient rule. It's just chain rule that I feel can cause some issues. Yeah, so for B and D, you're just finding f prime of 5 for each of these. So we should be able to look at this and recognize, okay, this is chain rule because there's only one x showing up, right? It's not g of x times h of x, it's g of h of x. So there's a nested relationship here. So outsize derivative times insize derivative. Replace every x with 5. And then take it one piece at a time. You know that this is not going to be able to be done in one step. We have to kind of take our time with it. So do the piece that feels manageable. We know we can figure out what h of 5 is. Once we get that to a number, then we can find g prime of whatever. So we know h of 5 from our list of values. H of 5 is 3. So I replace that with 3, but now I can take care of that outer portion, that g prime of 3. They don't give us a value for g prime of 3, so we just have to leave it as is. But h of prime of 5, we can replace with -2. As far as we can go, since we don't have enough information about g prime of 3. Any questions with part B? All right, part D. F of x equals bracket g of x cubed. This is a function within a function, but notice that it's a little different than part B because part B, both the outside and inside function are in function notation. But here, the inside is function notation, but the outside is something that we can apply power rule for. So there's a mix. But we just follow the rule that we need to do. This is definitely an outside, inside. So the outside we'll do bracket cubed, and the inside we'll do g of x. You already see that there's a need for chain rule here, and that there's that outside, inside breakdown of our functions. So let's do one piece at a time. Let's do the outer portion first. What's the outside derivative? Bracket cube becomes what? Yeah, we can do power rule there, right? So that we can do power rule. 3 bracket to the second power. What goes inside here? Just what? Just g of x. Yeah, no derivative yet. We haven't gotten to the derivative portion of the inside. Now we're done with the outside portion. Now we move on to the inside. But the inside is in function notation, so g of x just becomes what? Just what's the derivative of g of x? And well, this is in function notation, right? So what can we do to g of x? G of x would just turn into what? Just g prime, right? So if something is in function notation, we have to leave it in function notation. But if something can be done using power rule, then we apply power rule for it. All right, so now replace every x with 5. And then let's see what we can replace, right? G of 5 gets replaced with -3. G prime of 5 is 6. So 27 times 6. It's a big number. I want to do a different variation of part D, where there's a mix between function notation and non-function notation with chain rule. So if you guys can cross off C, and I want to do f of x equals g of x over 2. And this time I want us to find f prime of 10. Now this x over 2, what's another way to rewrite it without having to look at that denominator fraction? X over 2 is the same thing as what? No, something with that 2. Where can we put that 2 so that it doesn't feel as, I guess that's kind of, intimidating, because we don't like to see fractions. Or we don't like to see a number below the variable. Is there another place that we can put that 2 so that it's not below the variable? Dividing by 2 is the same thing as what? Multiplying by 1/2, right? Now, it may not be a big deal for you, but I feel for most students, they would prefer to see 1/2 x than x over 2. But if it doesn't impact you, then great, no issues there. So this is definitely an outside-inside relationship here. What's the outside portion? Outside is what? G. Okay, so we know the outside is G. And the inside is the 1/2 x. So we'll do the outside first. What does G become? G just becomes G. What's the derivative? Yeah, G prime. So G prime, and what goes inside the parentheses if we were doing G prime? The same, right? So just what? Just 1/2 x. So now that we're done with the outside derivative, we can move on to inside derivative. What's the derivative of 1/2 x? Just 1/2, yeah. Right, so now we can plug in 10. So this becomes G prime of 5, and G prime of 5 is 6. 6 times 1/2 is equal to 3. So I want to just make sure that we can apply chain rule in all of these different variations. Sometimes both the outside and inside are in terms of variables. If they are, then we just do G prime or H prime. If the outside requires power rule and the inside is function notation, then we do power rule, and then we do the function notation for the G prime. But this is the other way around, where the outside is the function notation, the inside is power rule. So we always do outside first and then inside. So I wanted to see all the different variations so that no matter what you see on the test, you can adapt accordingly. All right, let's do one more set of chain rule, and then I want to talk about vertical and horizontal tangents. So let's do 115. See, can you try 115 on your own, A and B, and see if we can just have no issues with chain rule, and that way we can be confident when we see it on the test. Once you try it, you can check the key on the next page. Okay, so let's go over it. Part A, we're trying to find R prime of X. r prime of x. F is the outside, g is the inside. So f prime of g of x times g prime. Replace every x with 1. Take care of what feels manageable. G of 1 feels manageable. G of 1 is 4 based off of the G of 1 is 4 based off of the graph. And then replace G of 1 with 4, and then move on to f prime of 4. F prime of 4 is asking for the slope of this line segment. So I can just count from one end to the other end, up 5 over 4. And then G prime of 1, we're asking for the slope of the G graph at 1, and this is part of a horizontal line, so G prime of 1 is just going to be 0. Anything times 0 is just 0, so R prime of 1 is equal to 0. Part B, S prime of X. So outside's derivative, G prime first, and then the inside's derivative, F prime. Make sure that you don't do G prime of F prime. There's always that inside portion that is going to remain unchanged until after we get out of the outside portion, and we can have the inside be its own derivative in its own space. Okay. Replace f of 4 with the y value, and f of 4 looks like it's around 2.5. So I did 5 over 2, but you can say 2.5. And then the slope of the f graph at 4 is 5 over 4. I'm just counting rise over run for this line segment. And then 2.5 on the g graph is somewhere around here. So I just have to figure out the slope of this line segment. So I just pick 2 points, up 1 over 2, slope is 1/2 times 5/4 equals 5/8. Okay. Let's go to page 24. This is vertical and horizontal tangents. So typically these are reserved for equations that require implicit differentiation, because these are graphs that are not functions. Typically, that's where you're going to find horizontal and vertical tangents. So for instance, if I had a graph that was like an ellipse, for instance, or a circle, I can expect multiple places of horizontal tangents, right? Where if you skim the surface of the graph is going to experience a slope 0. And then there's also multiple places where there's a vertical tangent where the slope is undefined, where if I skim the surface of the curve, they give me a vertical line. So if I see an ellipse, I can expect 2 horizontal tangents and 2 vertical tangents. And the way we can find those locations is to find a horizontal tangent, we're going to be setting the numerator of the derivative equal to 0, and that can help us find the locations of these points. And to find a vertical tangent, I'm going to set the denominator of the derivative equal to 0, and that will help me find where the slope is undefined. But before we can do any of that, we have to get to the derivative. So to get to the derivative, we have to go through implicit, because we see y's all over the place. So let's go ahead and find the derivative. The nice thing is it's just power rule. So there's no there's not going to be any chain or product or quotient rule. It's just going to be power rule. But we do have to keep track of our dy dx's. How many dy dx's do we expect to show up? 2, yeah. Okay, so try that. Go through the steps. I've got the key attached so they can see on page 26, but I'll work through it as well. So this is going to be where we're going to gather all of our information. The numerator will tell us where the slope zeros will occur. The denominator will tell us where the slope undefined will occur. The direction says find the points at which the graph has a vertical or horizontal tangent. So after we find our x or y value, we have to plug it back into the original equation to find the corresponding x or y value. So once you solve for x, we're not quite done yet. We know the x value location. We don't know the y value location. So we have to take that -4 and plug it back into the original equation, figure out the y values. And because this is an ellipse, we can expect two horizontal tangents. So we're going to have x is -4, but then you're going to have two different y values. They're going to be above each other. Constants cancels out nicely. I'm left with two terms. I can factor a 16y out because there's only two terms and I have a 0 on the other side. So likewise, we can find vertical tangents. We can find locations of these points where the slope is undefined. Set the denominator equal to 0. In this case, we'll solve for y, but once we solve for y, we have to plug it back into the original equation because we have to find that corresponding x value. Okay, any questions here? There's one more big topic that we haven't gone over yet, and that is piecewise functions, finding an a and b value if the graph is continuous and differentiable. So that'll be our focus for tomorrow. And then we can do more particle motion problems. We saw it on the quiz, but I just want us to have more practice with that. So your homework tonight is just to finish 58. Just one problem here. Once you guys get some extra practice, and so that when you see it on the test, you feel comfortable with the process. Okay. All right, complete your phones. Help session tomorrow morning and Friday morning. You okay about this? All right, great. Thank you. You'll come in. Yes.